Hello and welcome to Historical Geology, and today I want to look at the stratigraphy lab. A lot of this is background information and I talk about this in my video lectures, so read through this obviously after watching my videos and taking notes from lecture. You'll have a better understanding of these concepts as well. This activity 1.1, this is kind of more of like a preparation, almost like a pre-lab dealing with unconformities. And I want you to answer these in your own reasoning. I want you to state something here you start thinking about how we think about these erosion events and where they form. For example, a mountaintop should be a region that's a source of erosion instead of a source of deposition, right? So you're not depositing stuff on top of the mountain, you're really taking away and bringing that someplace else. So thinking about that when you're answering this activity 1.1. And then again, this deals with unconformities here. And then when you're getting to this next part, there's a lot of terminology and it's a little confusing in terms of these lithostratigraphic units, biostratigraphic units, chronostratigraphic units. There's time units, so it's time transgressive units. And then again, more units. The key thing about the lithostratigraphic units, in fact, in the lab, they call this the stratum, right? So they also call these stratum. Let's add that word here, stratum. And the basic unit of the stratum is a formation, but you see that there's members and beds, and then bigger groupings are called groups, right? I think like the Grand Canyon supergroup would be the Grand Canyon Tonto group is a mauve right angel and the Tapi sandstone. And some of the older units down below, like the Unkar group or the Grand Canyon supergroup, would be some of the older formations that exist before the Tapi sandstone here. But anyway, it's a little bit about more terminology here and how formations need to be mappable and thick enough and distinctive enough from each other. And then for the biostratigraphic units, again, they're based on the fossils, and it could just be one species or several species that may define that biostratigraphic unit. And we've done a little bit of this already in the Geologic Time Lab. For the example I have here, so we have these different species here, and I've labeled them A, B, C, D, and E here just for simplicity. And you'll find that they're overlapping age range. So if all those brachiopods existed in the same rock, in the same limestone, then what would be the age of that limestone, even though each individual species or taxon has a wider range of distribution here when they lived. And so we find that the overlapping age range, so in other words, fossil C here, Leptenia, would be our limiting factor. We can't be any younger than that, because if we were looking at rocks younger than Mississippian, we would not find this fossil in that rock. So that would be our upper limit right there, upper boundary. And then for our lower boundary, we see that we cannot go any lower than this fossil B, right? Middle Devonian or mid Devonian. And so the age of this limestone would be mid Devonian to late Mississippian. Right, mid-Devonian to late Mississippian. Where did I put it? I think I put that up here. Mid-Devonian to late Mississippian, right? So using those concurrent age range. And so know those because on the exam, I have several examples like these where you have to do these overlapping or concurrent range zones to figure out the age of the rock unit, right? So, and then other things we look at, and you'll be asked to do this in the lab as well, is trying to identify the range zone of an individual species. That would be the taxon. And so in this case, it's just looking at the range zone for E. Here is the overlapping or concurrent range zones of A and B, right? So it'd just be in this region right here where they both overlap in time. And then this interval biozone, I don't really use it too much, but it separates two events. In this case, the origination event between fossil D and fossil B, right? So these can be, I think I have it up here, intervals between two origination events, intervals between an origination event and an extinction event, or two extinction events, right? So it's between two events, right? And in this case, they're showing it the interval between the origination events between fossil D and fossil B, right? All right, so as we go along here, looking at the time stratigraphic units, so read about these time units and then how we divide the rock divisions versus these time units. You can read about that. Yeah, again, here we're looking at more of the terminology and another picture or figure showing the range zones of each taxon or species, right? And so here's Oleanellus and Elrathia. And I think I talk about Phacops and Oleanellus, so kind of read about what I discuss here on for figure 5 there. And now for activity 1.2. So all that was just kind of background information that we need to understand before we can actually start addressing some of these problems. And for activity 1.2, we're looking at this figure and we have two different species or taxons. We have the fossil F1 and fossil F2. And our job is to figure out what their range zones are. We're going to draw that here on this figure. So in fact, let's click on that and we'll edit this figure a little bit here. Now, the first thing that's going to ask us to do is to label the different periods, starting with Cambrian and going through Mississippian. And so you can just do that right over here. So C is for Cambrian. Then we have Ordovician. Then we'll have Silurian, and then Devonian, and then finally is Mississippian. All right, so that's the first thing. We established our little geologic column there. And now for the range zones, you see for fossil F1 or fossil 1, you'll see that it goes from Cambrian, Ordovician, Cambrian, that's Ordovician. It goes through the Silurian, right? So we would mark a heavy line here. So let's put a line here. Let's make it a heavy line here. And so it's going to go from Cambrian up to Silurian right there. So that would be the range zone for fossil 1. So you do it in this little column here. And for fossil 2, we see that it goes from Silurian, Devonian, Mississippian, right? So we would start here from the Silurian and go up here to the Mississippi. So that would be the range zone for fossil 2. Now, you'll see that there's going to ask you some questions. And again, here they're going to ask you questions for, what would be the age of the rocks here in unexplored region 4 and unexplored region 5. And so based on the fossils, we can say something about it. For example, this one, since it only has fossil 1, then this is going to give us the age of these rocks, or at least this limestone right here, can be anywhere from Cambrian to Silurian. We can't narrow it down any more than that. But the fact that this one has both fossils, we can narrow this one down to 1 period. So I'll let you take care of that. All right, so you can finish that problem up there. And for activity 1.3, again, we're doing more of these biozones. And we're looking at a number of these Paleozoic brachiopods. And you'll see that they're pretty important species for the Paleozoic. And by filling out this chart, you're going to understand their importance. And I've done that already based on, and so the ranges of these fossils are given back here on this figure, I think it's figure 7, yeah. And so you look, for example, Atripia here is Silurian to Devonian, right? So you would mark out that region, Silurian to Devonian. And you want to note whether it's middle to upper or lower to some. So in fact, I've done it on mine, and see if I can show you here. And you want to show these heavy dashed lines on there for each individual fossil species. I don't know if you can see that there. And make sure you get this correct, because I will be checking this when you submit this in the lab. I want to see your work. And again, it's going to introduce you, or at least get you more familiar with brachiopods, because once we start looking at fossils in the coming weeks, you'll find that brachiopods are going to be your friends in helping you identify, or at least figure out the ages of Paleozoic limestones in particular. And as we go along here, this next sequence deals with transgressions and regressions, and I talk about these in my video lectures. I talk about them I have kind of demonstrations, video demos on Canvas for you to look at. But the key thing, remember, there's this lithosphaces suite, and it always involves like a sandstone facies, shale facies, shale or siltstone, and limestone facies. So a transgression would show, in fact, in this model here, they're showing sea level at time 1 here, And then you'll have like sandstone here at the beach. A little bit offshore, you're seeing the muds to make the shale and the siltstone. And in deeper waters, you're seeing the carbonate sediment forming the limestones. But as sea level rises, up here we're at sea level 2, shoreline 2 here, note the sandstone facies has moved up onto land, and now the shale facies is now depositing on top of that sandstone, and the limestone facies, deeper water facies, is now depositing on top of that shale. So there's a progression, or a lithofacies progression, where we have sandstone, and then we have shale on top of that, and limestone on top of the shale. That marks a transgression. If we saw the opposite, and I think I have that back over here. Yeah, so if we saw sandstone on top of shale on top of limestone, this would tell us that sea level was much higher, and as the sea level was dropping, now the sandstone facies will be on top of the deeper water shale facies, and the shale facies will be on top of the deeper water limestone facies. So that would mark a marine regression, right? So here's a transgression right over here, and this is a regression. So again, this is the same figures I use in my video lectures and the little demonstration I have on Canvas for you. Now, so your job here for activity 1.4 is to look at these, right? Try to figure out whether that's a transgression or regression, and then work on this next figure. And here on this figure, we're figuring out the units. So 1 to 7, you can just put them on the side here. And what I would probably do for this one and the others coming up here, we could say, well, letter F will probably be number 1, right, the oldest. And then this will be 2, and this will be 3. And then letter C here would be 4. But now we have this unconformity here. And we want to put that here as our 5th event. We'll put it off to the side here. We'll put 5, and let's label that that's going to be some unconformity. So that is an event. It's an erosion event, right? So we want to document that unconformity. And then for letter B here, that's going to be our 6th event. And finally, the youngest event is going to be number 7, which is the one on top here, based on the principle of superposition. So you do want to make the unconformity one of your events. And then you can tell me what type of unconformity that is based on what you see there. And the same thing with this one. You're figuring out the geologic puzzle. You're going to put your events on the bottom. So obviously in this one here, it looks like we're going to use a principle of superposition to begin with. And Q is going to be our oldest unit. And then above Q has to be P, O, N, and then we get this activity over here. So you can write those on the side here to show your units. All right. And then all right, so this next activity, or printing these stratigraphic columns, and I've done the first one where there's a second one here as well. And I also have, I think I put them in here in the lab as well. Yeah, so they're right in here as well. But the first thing you'll want to do for these sheets is to use a ruler. And you want to use a ruler to connect in fact, in this case, we're doing a lithologic correlation. We're correlating the units based on their lithology, like sandstone to sandstones, conglomerates to conglomerates, right? And their relative order, right? And so in this worksheet 1, we draw the lines like I've done there. Then you want to color the areas using the key in table 3. And I used it, you can see I've tried to follow those directions here. And I didn't have black, but I used gray for my black. But you can see I did follow the other ones there. And then once you've colored it in, you want to make sure you color it in. You want to use table 4 to name the lithologies, right? And so you can see these different patterns refer to some sort of rock type. And so in table 4 down here, I use this to name the rocks. And you want to put the names of them somewhere like that. And I think they give you an example here in the lab. And yeah, so you can see that here's the example that they're giving you here in the lab as well. And then once you've established that, the next step, on the left side of the worksheet, the stratification is divided into 3 distinct segments. So they're talking about, actually this only has 2 segments here. This segment up here and the one down here for the first one. Divided into, it should be 2 distinct segments. Each of these segments corresponds to a transgression or regression. So your job is to tell me whether you circle T or R to tell me whether it's a transgression or regression for both of those.